Hi, I promised I'd do a follow-up video showing an unusual issue I had with my new solar power system I had installed, the Enphase system, and also to do with my old Solar Analytics system as well, because I've got essentially two separate systems installed. I've got my original 3 kilowatt solar array installed, hooked up to my existing Sunny Boy SMA string inverter, which is monitored by a Solar Analytics system, and I've done videos on all these things. I'll have to link them in if you haven't seen them. So that's a complete monitoring solution. We just move that 3 kilowatt system from one side of the roof to the other, so then we can have room for the more optimized new 5 kilowatt Enphase system, which has the 14 Enphase microinverters going into the Enphase Envoy monitoring system, which we have here. So these two systems are totally independent and they're running side by side. So I've got two different generation sources, two different inverter systems, and two different measurement systems. So yep, I've got two different systems here, and I can access the data analysis and graph pages for both of them. So the Solar Analytics, this is my old 3 kilowatt system thing. This is back on the 29th of March, so basically installed at the start of the month, 1st of March. So this was just before I stored it, and you can see the yellow is the production curve, i.e., energy coming from, or power coming from the panels. It's not energy until it's over time. Power coming from the panels. So at each moment in time, that's the peak power there. So 2.3 kilowatts produced, etc., etc. And the purple one here is how much I'm actually consuming during the day. You can see during the night I've got 2 fridges. We're running 2 fridges. So that's, apart from any like phantom power devices, standby power, that's pretty much all we're running. So only like, 150, 200 watts or whatever during the night for the 2 fridges. And then we, nobody's home during the day. Then we come home, we use some appliances and we switch them on and all that sort of stuff. Everything's hunky-dory. We've got energy produced and energy consumed. And then something interesting happened. After we did the installation, that's the day we installed it, so don't worry about that. And then the next day, this is what I started getting on the exact same Solar Analytics system. All we did was move the panels from one side of the roof to the other side of the roof. What's going on here? You'll notice that the purple graph now goes negative. Negative 4 kilowatts consumed. What? How do you get a negative consumption? That's a bit weird. And then, at like 6 p.m., it goes positive again. And what's going on here? Well, it turns out that this is actually a very common issue when you have two systems installed independently side by side like this, and they're not, well, I'm not going to say not installed correctly, but they're not set up correctly, and they don't know that each other exist. And a lot of people who don't monitor their data just ignore, like you would just never notice this sort of stuff. All you care about it is your net metering. That's all they care about, is how much electricity they pay. But, nerds like me who follow the data, it's like, what? It's gone negative. So it turns out this is actually a relatively common problem when you have two different systems installed like this. Doesn't happen if you just have one system installed. And there's actually a fairly simple and clever solution to fix this. So let's go through it. Just a quick check though of the Enphase one. This problem not only happened on my old 3 kilowatt system here, it also happened on my Enphase one. This is where, like, it was installed here, but I don't know, they didn't switch the data monitoring on until there. And look, 200 watts consumed, and then during the day, this one's the yellow one, is the actual consumption in this particular case. It's going negative, minus 880 watts consumed. And then mysteriously, at night, the consumption goes positive. What the? Now, when I posted this on Twitter, quite a few people said, oh, your current clamps must be installed backwards. And that, seems a legit thing because, well, after the installation, we're now getting negative current consumption, right, on both of these systems here. It turns out, no, the current clamps weren't on backwards. So if you aren't aware, it's current clamps like these ones that they install on these monitoring systems to allow you to measure the current, not only from your solar panels, so you can measure the production power coming from your panels, but you can also measure the consumption of your house, and you can measure the current going out to the grid as well. And you can see, maybe you can see just on the top of there's a little arrow, and you have to install these the right way. And sure enough, if you install it back to front and the current goes in the other direction, then, well, it's going to give you a negative output. And yeah, that's a real thing. You've got to install them the right way. But that's not what's going on here though. So anyway, let's go back to this graph here. Now, you might notice the shape of the production curve, i.e. the sun, right? So the sun is producing this yellow curve. It just so, look, it dips here. And then the purple is the consumption. The purple also dips when the sun dips. What? Look, it's almost like they're a mirror image of each other. What's going on? So it turns out this kind of mirror image thing is not a coincidence. There's a reason that the consumption matches what the sun is doing, and why when the sun goes down at, like, it's all gone at like 5 or 6 p.m., our consumption suddenly goes positive again. Can you pick it yet? Stop this video and try and figure out what could possibly be wrong with two systems on your roof and two different measuring systems giving the same negative power during the day. And once again, if you zoom into this, you'll find that the envelopes, once again, they match here. So the orange one consumed goes up when the value drops, and look, and even during the day, look, it actually went positive like this during the day when that was up. So see if you can figure it out before I give you the answer, because it's rather a subtle thing, and you've got to put your thinking cap on to figure out what's going on here. So the best way to explain what the problem is here and how it's solved is to go over to the whiteboard. So let's take a look at the potential problem you have when you have two separate solar generating units like this and two separate monitoring solutions like this connected to the one house. Now, we've got our grid up here it is, and we've got our line coming in. Now, of course, the power can either be coming in from the grid like this, or it can be going out, depending on whether or not you're consuming all of the power from the panels. If you're producing more power in your combined solar arrays than you're using inside your house, you're going to be exporting out to the grid. But if you're consuming more in your house down here than your poor panels can provide, or it's nighttime or whatever, then you're going to be pulling power from the grid. So current can both flow in from the grid and out to the grid like this. Now, in this particular case, we're going to look at my exact example. We've got the 5 kilowatt system, the new one with the Enphase micro inverters. And then we've got the existing 3 kilowatt system with the Solar Analytics monitoring system. Doesn't matter that it uses a Sunny Boy string inverter. We're just looking at the Solar Analytics is the monitoring system that we're using. And the Enphase Envoy is the monitoring system we're using for this. The inverters don't matter. So both of these systems, indeed any solar monitoring system, is going to be measuring the production, what's called the production, i.e. the power, the current flowing out of the panels like this. So they'll have that little current clamp transformer around, physically the one wire coming from the Enphase inverters. And remember, this is after the inverter, so this is after it's generated the 240 volts required and put it onto the main. So as I said, doesn't matter whether it's a micro inverters up here or a string inverter. This has nothing to do with it's not actually measuring the DC, it's after the inverter. So measuring the production from the panels is easy and simple. You can't goof it up, you just put a current clamp on there and it goes into the input to either the Enphase Envoy monitor or the Solar Analytics monitor. So each system has its own current clamp measuring that. And as we saw, that wasn't the problem. Although, as I said, you can actually put the transformer on back to front if you goof it up, and well, you'll get negative. But that's not what's going on here. What's going on here is we have a problem measuring the consumption, the load. Why is it going negative, and why does that pattern follow the production from the panels? I.e., why does it follow the sun? It's negative during the day and it's positive during the night. What's going on? Well, this is where it gets a little bit tricky. Now, of course, the obvious solution is to simply have a current clamp on here that measures the load like that, and of course you'd have a second one here, and that would go up into there like that. So each system knows about the load and consumption. And once again, you can't really goof that up unless you put the current clamp on backwards, but then it'd always read backwards. It wouldn't go negative during the day and then positive during other times. So what's actually going on here? Well, it has to do with the Switchbox and the sort of limitations in there for being able to put these load measurement clamps. Right, so let's have a look at our Switchbox here. We'll expand that out, and we've got like a 60 amp breaker here. This is like the main one for the house. Just like go with these numbers. They're different for different scenarios. But then like inside the Switchbox, we've also got the 5 kilowatt solar arrays wired inside here as well. The 3 kilowatt solar array, so it's pumping that in. And then you've got this wiring. Once again, it's all in parallel like this, like goes through to separate breakers for like each power point circuit might be 20 amps, for example. Light circuits might be 8 amps. You might have like oven, stove, or hot water, you know, different fuses like this for different parts of your circuits. But the problem is all of this stuff in here is like all higgledy-piggledy. It's all kind of like wired together into points and all. It's a real rat's nest of a thing. That's how it is in my particular fuse box. So unless you had a fuse box that had like one wire coming off here like this and then going out into all these ones like this, you would have to like break this off like this. Instead of separate wires, you'd have to have one wire there, which then just went to all the other breakers like this, so that then you could put your current clamp into there and you could take that reading off there. But because your power board is like, it's got one thing coming in here and then it's, you know, like, because the power can come back in here and it's all run on the same wires and it might flow out like that, but it might flow back in. It's all a mess. You want to measure just your isolated load for your house down here. So the physical construction of your fuse box and the fact that you have all these different fuses for all these different circuits and it's all wired in there all together and they're effectively like all just in parallel, then it makes it quite difficult, not impossible, but difficult on lots of fuse boxes to be able to put one simple current clamp in there. And so that's why it's actually common practice to put the clamp outside of here and put it up here like this. So the current clamp for the consumption actually goes on the grid side like this. So that goes in there like that, and you would have another one, a second one like this, that then goes down into there like that. So just from a physical wiring access point of view, it makes sense to do that. But now you can probably see the problem. What you've got now is a situation where each of these monitoring systems does not know about the other one. So if you've got your current clamps outside of here, the easiest way to understand it is just to put some numbers in. Let's say that here our house is taking 1 amp, okay? And our solar systems here are generating 2 amps each, right? The sun's out, they're both generating 2 amps, okay? So we're drawing 1 amp into the house and we want to read that as a positive number. We want to read, this Solar Analytics system wants to read 1 amp. But what it's actually going to read is the total production from the 2 different systems, one of which it doesn't know about, 2 amps plus 2 amps. So there's going to be 4 amps pushing in this way like this, 1 amp's going down here. What's going to happen? Well, you're going to get 3 amps flowing out like that. So during the day, because your current clamp's there, you're going to actually get a consumption reading of minus 3 amps because the current's flowing out, not in like you're trying to read. And then magically, night falls, this drops to 0, this drops to 0, and you're still drawing your 1 amp load. Instantly, you're now not reading minus 3 amps because there's nothing flowing back out. You're drawing everything from the grid. You're going to have, flowing that way, you're just going to have your 1 amp. So it's going to start reading correctly once the sun goes down. Now, during the day, when you've got your production curve like this, of course, you've already got the clamp on your 3 kilowatt array here. So it knows how much this one's producing, right? So it can actually take the example that we had before during the day, 2 amps here. Okay, so let's add the axes here, like 2 amps. Let's say during the day, the 3 kilowatt system's generating 2 amps like this. It knows about that because it's measuring, but it doesn't know about this system up here. So the output that this clamp here is measuring is actually 4 amps. It's not 2 amps because you've got the extra difference in here, the extra 2 amps caused by this array here, which it doesn't know about. So even though having the current clamp here is a perfectly fine solution, but only if this one doesn't exist. Then it would know how much it's actually producing, and then it could subtract the consumption from that figure and give you the correct positive figure always. But it doesn't, because this is pumping an extra 2 amps into this system inside here. And likewise for this Enphase system here, it's got no idea that this other system here is pumping out 2 amps here. All it can measure is its own production plus the consumption up here. So during the day, it's gonna show negative as well. It's gonna show that it's exporting energy when you're actually consuming it. So how do we solve this? Well, you can actually solve it simply by paralleling current transformers, because what is a current transformer? It is simply a core like this, iron core, and it has a bunch of turns on here like this, and it's simply a transformer. And your wire going through like this is 1 turn, and you've got multiple turns here. So if you've got your 1 amp flowing through here like this, you might get 1 milliamp flowing out of your coil like this. So what you can do is actually wire a second current transformer in parallel with the first one onto your other, coming from your other production line up here. So this input has 2 current transformers, one to measure the production from here, another to measure the production from here. And in this case, if you've got, say, 1 amp production here, and you've got 2 amps production from the other panel, then you get 1 milliamp out of here. Let's assume it's, you know, like 1,000 to 1 turns ratio. Then you've got 2 milliamps coming out of here because you've got 2 amps here. So you'll get a total of 3 milliamps, which is the total of the production of these 2 systems. So bingo, both systems, the Solar Analytics and the Enphase, will now know about the total production, so that then you can have the load measurement transformer, current transformer, outside here like this because of the limitations of your Switchbox, and then you're always going to get a positive value because it now has the correct value to subtract. You got it? Clear as mud? I could probably make this easier, but you get the idea, is that each system doesn't know about the production from the other one. And the way to solve it is to put 2 current transformers in parallel on each one. Of course, if your system had like another input here for production and you were able to set it up in software and things like that, then you could do, you could do the same thing. But even if your system only has the 1 input and it's not designed to measure multiple arrays, it doesn't matter. Just wire the current transformers in parallel so that your system knows about the total consumption. The only downside to this configuration is that if you really wanted them to be separate and you wanted this, say the Solar Analytics, to only measure the total production from here, then there's not really much you can do about it. You can't really accurately measure the production and the consumption at the same time from this isolated system with the current transformer up here. You would have to move the transformer down to here. You would physically have to have it down there like that. So anyway, as a lot of installations like my one, that's not really practical. So that measurement load transformer has to be on the outside. And it turns out that Enphase do actually know about these sort of installation issues. And if you go over to the system over here, we can actually look at our, they've now added the photo on there, by the way, which is quite nice. So this is now like a real photo of my roof with the actual panels installed in there, and I can actually go and like look at individual data and graph for each particular one. Here's the temperature, for example. Like you can get the temperature, like that's the temperature of each microinverter, not the actual panel, but it's interesting. But anyway, if we go over to devices over here, okay, and we take a look at our Enphase integrated consumption meter, right, which is part of the Envoy thing, check it out. They've actually got the two configurations here, and the one mine's set up to is the load with solar production. So the Enphase system knows it's supposed to subtract the consumption from the production because they share the same current clamp and they're on the grid side. But you can actually change it to, if you happen to have a panel that allows you to install the current clamp on the load like this, then, well, the load data, which is the problem that we've been having with this thing, whereas it was the load, the actual consumption data, which was being goofed up and going negative. The production data always worked. It was the load one that was goofing up. Then it knows that there's nothing else it has to compensate. It doesn't have to compensate for the production of these two panels. But even though the Enphase system has support for this, you saw how it goofed up right at the start because there's no way that the Enphase system can know about the production from the other system installed. Even if there was like a field for an offset or something, it's a variable figure. So how does it know? It doesn't. There's no way it can know you've got another solar production system panels over here actually pushing current back into the grid or into the load. Alright, so let me show you what's happening on the switchboard here, and please forgive me, this is a bit difficult. You need like 3 hands to keep the switchboard open, unfortunately, and like poke at things at the same time. Anyway, here's our main 60/80 amps, I don't know what it actually is, but main breaker main fuse coming into the property. So this is the side that we want to actually put a current clamp on to measure both the incoming and like consumption coming in and also going back to the grid as well. So that needs a current clamp on it for both the Solar Analytics system, which you've seen before. I've done a whole video on that, and there's the 3 current clamp inputs down there. And I used to have one channel for the production, i.e. coming from the solar panels, another for the consumption, i.e. coming into the house, what we're actually consuming, and then another one that did the air conditioning as well. But I'll explain air conditioning consumption, but I'll explain that in a minute. And of course we've got the new Enphase Envoy box up there, and so let's have a look at what's actually going on here. So let's have a squiz around the back here, and yeah, this is not the best, is it? But anyway, as you can see, we've got 2 current clamps there. There's the Solar Analytics current clamp, and there's the Enphase current clamp, and both of those are on there. They are directional, so you have to actually get the direction correct on those. So both of those are measuring the current coming into and out of the property. So it depends on which way it flows as to whether we're consuming power or we're actually exporting power to the grid. And here's the breaker for the main existing 3 kilowatt system, and if we go around here, you can see how it comes out there, and it's got once again 2 current clamps. That's the bigger one there is the new Enphase one, and the smaller one just down in there is this Solar Analytics one. So both systems now actually are able to measure the current. They know what the current is coming from the existing 3 kilowatt panel. Okay, I'm trying to keep this panel open with my elbow, but anyway, you can see another clamp here. This is the Solar Analytics clamp, and this cable here comes from the AC from the new panels. Okay, so the new 5 kilowatt system. So this is what we had to change. This one was actually measuring the aircon system before, but I've now sacrificed the measurement of the aircon power. That's just now included in the total power, and I've moved that to actually on here to measure the current coming from the new 5 kilowatt system. And I've put that in parallel. You'll notice that it's got a red marker on there, and the other one down here is brown. So I've wired both of those in parallel in there on that first channel up there, and the existing one on channel 2 there, which actually measures the current coming into and out of the house up here. So by putting the 2 current clamps in parallel on channel 1, the Solar Analytics now knows the total consumption of the entire system. So then it's able to do the basic addition and subtraction required to figure out how much current is being consumed by the property, and it was totally unknown before. So this solar analytics system is now aware of both production sources here and here, and likewise up in there, I won't show you, but they're also paralleled up in there as well. As I said, there's one here, and you can see actually the arrow there, so it's actually coming out of here, and it's measuring the production coming from the 3 kilowatt system, and it's putting that effectively in parallel with another current clamp, which is actually up in the box there rather than in the switchboard, but it's doing exactly the same thing. So both the Enphase system and the Solar Analytics system now are aware of the two different of each other's sources, and that's not done in software. That's done by simply paralleling up the current clamps, because that's how they work. They're magnetic current clamps. They're not active electronics. You can whack them in parallel, and then you just get the combined current out of both of them. So there you go. I hope that is clear as mud. And this is one of, you know, the major issues with having two different production systems, i.e. two different solar panel systems on site, is that they're always going to combine like this. And really, unless we totally scrap this entire switch box, may do eventually if we install a battery system, that's the recommendation, is to get rid of this ancient thing. Although it's not that ancient. This is mid-80s. This house was built in the mid-80s, so this is a typical style that was in back then, well, at least in this area anyway. And it's not uncommon at all. But anyway, just due to the physical wiring configuration of this, we weren't really able to put the current clamps on the sort of like the house side of the meter. The only place we could really put them is over here, and which is the main feed coming in from the street. And well, that just screws everything up when one system like this one doesn't know about the production from here, and this one doesn't know about the production from here. So you solve that by whacking transformers in parallel. Neat. And I didn't have to buy a new transformer. I just reused one from my aircon. So now my Solar Analytics can't measure the aircon separately, but no big deal. So anyway, I hope you found that interesting, because it really is an interesting scenario caused by a physical space wiring configuration issue inside the Switchbox. If you had a Switchbox that, as I said, enabled this measurement inside here, and you could easily put the current transformer there to measure all these different circuits at once, then, well, everything's hunky-dory. But in my case, and a lot of cases out there, you can't do that, which is why software like the Enphase system actually has a specific setting to tell you where you want that current transformer, because this is a known issue in the industry, and you can fix it by putting transformers in parallel, but there is that slight limitation that you can't then independently measure things, and it's all too hard. So anyway, I hope you found it interesting. If you did, please give it a big thumbs up. As always, discuss down below. Catch you next time.